Okay, guys, let's start. So we'll continue with something called specific heat capacity. Anyone can define specific heat capacity? Yes, Sabrina?
The amount of energy needed to raise 1 kilogram of a substance at 1 degree Celsius.
Fantastic, that's the actual definition. She got it right, okay? So specific heat capacity, the symbol is C. Specific heat capacity is the amount of heat Q required to raise the temperature of a kilogram object by 1 degree Celsius. Very good, you got it right, okay? So C stands for specific heat capacity, Q stands for heat absorbed or released. Heat absorbed or released. And then M stands for mass. Okay, this is in kilogram. What's the unit for heat, guys? Joule, that's right. Delta theta means change in temperature, guys. Okay, change in temperature. And what's the unit for change in temperature? It could be degree Celsius or Kelvin, okay? So either one is fine. So the unit for C is, what's the unit for C? Joule kg minus 1, guys, degree Celsius minus 1, or Joule kg minus 1, come on, Kelvin minus 1. Is that okay?
Yes.
So that is the equation for specific heat capacity, but don't just look at the equation, try to understand, alright? So the C for water, it's 4,200, okay? Joule kg minus 1, degree Celsius minus 1. Okay, the C for aluminium, it's much lesser, but let's say 900. Joule kg minus 1, degree Celsius minus 1. Now, you need to understand what's the meaning of a big C and a small c. What's the meaning of a big C and a small c? Yeah, Sabrina.
One is internal energy.
Sorry?
Something one has to do with internal energy.
Internal energy, don't have to go to that. Just based on this equation here, guys. I want to try to relate C and the change in temperature. This is very important, guys, okay? C and the change in temperature. So what do we observe, guys? Inversely proportional. So what does it mean? If you have a big C, the change in temperature will be bigger or smaller, guys? Smaller, exactly. It's inversely proportional. And again, let's go to some understanding, alright? I have a same amount of heat. Same amount of heat, okay? I use it to heat up water. And I also have the same amount of heat. I use it to heat up aluminium. The water temperature will rise faster, or the aluminium's temperature will rise faster with the same amount of heat. Aluminium. Yeah, you got it right.
Just the heat.
Okay, why?
Because it takes less energy to heat it by 1 degree Celsius.
Exactly, you got it right, guys. Alright, so specific capacity is inversely proportional to temperature change. So the C, the lower the C, the higher the change in temperature. So therefore, you need just a lesser amount of heat to heat up aluminium as compared to water. Okay, is it clear, guys? Okay, I'll give you one daily application which is very useful. Okay, have you guys tried eating? Hold on. Right. Okay. Alright, so if you were to travel to Korea, okay, in Korea they have this famous noodle known as ramen. Okay? Ramen noodle, okay, in Korea or in Japan, alright? Okay, the same ramen noodle, okay? So this ramen noodle is made from, as usual, guys, noodle. Okay, what else do we have besides noodle?
Meat, spices.
Yes, spices, continue. What else?
That's it. Water.
Water, very good. Huh?
Hot water.
Sorry, good, water. Okay, that's right. What else?
Meat.
Meat. Meat, what meat do they use? Ramen.
Pork.
So sometimes vegetable, sometimes meat. Let's say chicken meat, alright? Chicken meat. Yeah, very good. Egg. Olive, you tasted before, Olive? Okay, you're right. Okay, egg. Okay, what else? Come on.
The green leaves.
The bamboo.
Vegetables, okay, vegetables, alright? Some veggie. Okay, some veggie here. Okay, vegetable. Okay, what else?
Oil.
Sorry? Oil, very good. Oil, okay. Oil, okay, oil. Okay, what else?
Sesame seeds.
Sesame seed, okay, some spices, okay, but you can't see the spices, so I'll just take the spices away, alright? So let's say you want to open a ramen restaurant in Braunschweig, okay? And you have all the ingredients right now. Okay, I just add all the ingredients. Hey, right now I've got a bowl of Braunschweig origin from Korean ingredient. I'd like to sell it right now. Okay, now you have the noodle in front of you. Then you have to think, hey, there are so many things here, okay? Which item should I first eat? Okay, so you must give us a thing, alright? So which item should I first eat? Okay, based on your experience, okay? Okay, who will start with soup? Who will start with the soup? Anyone? You start first drinking the soup. Okay, see there's one here, Shanna, alright. 2, 3, soup. Who will first start with noodle? 1, 2, 3, 4. Okay, good. Sado, what do you start with? Chicken, okay. Sado start with chicken, okay. Jason? Have you tried this, Jason?
No.
No, okay, never mind. We can get one from the Asian market. There's one noodle packet. You can just see it's quite tasty.
Get it for all of us.
Sorry?
We can for all of us.
Yeah, exactly. It would be nice. That would be nice. So, one day we can do it together. Alright, there's a kitchen over there. Alright, we can do it together. Alright. So, anyone else? Yeah.
Vegetables.
Vegetable, okay, so she'll start with vegetable. Very interesting. Let's write it down, okay?
Just mix.
So those you see Malik saying we mix. So Malik will mix everything and eat. Okay, so mix will be Malik. Okay, Malik. So Malik is one, right? Okay, so again vegetable. Vegetable will be who? Whom again for vegetable?
Me.
Okay, Obin, one, Obin, okay. Noodle again, right? Noodle, how many again? 1, 2, 3, 4, 5. Okay, 5 noodle, alright. So again, soup will be? The soup will be? 1, 2, 3, okay, soup will be 3, okay. So let's just play with this 4, okay. Why do you first drink soup? Those who take up soup. Why do you first drink soup?
Because I want to leave the noodles at them.
So Sado's like leaving the best for last. Sorry, Olim's like leaving the best for last. Olim, correct? Okay, anyone got a different idea why you drink soup first?
Because there's all the flavor in there.
A lot of flavors in there, so she want to taste first the flavor. Okay, very good. Who else? With soup.
But then the soup is too hot.
There you see. But then the soup is too hot.
No.
But if you're
You have to
frozen, it's
drink
hard
it when
to
it's
drink.
small.
You have to drink it when it's hot. You got an idea also, alright? But the soup is too hot. That's another idea. So, Fabian, you start with noodle, am I right?
Yeah.
Okay, why?
Because you have a lot from it. Like it's the most I don't think there's that much chicken, eggs, and whatever in there. So I would take the noodles first because that fills you up.
Fills you up first,
But the noodle is also hot.
But not so hot.
And then you
The
roll
noodle is
it.
also hot,
And then you
but not so hot.
But I can blow it.
Hey, but
blow it and then
hey, is
You
it
can
really-
blow the soup also.
Hey, but guys, they are all the same
and
temperature,
noodles
alright?
are-
It's the same temperature.
Are they all in the same temperature in the beginning?
Yeah.
Yeah, they all have the same starting temperature. Initial temperature, they are all the same. So you can't say this is hotter than the others. They're all the same hotness. Okay?
They cool.
If there's such word
cools
hotness,
down
right?
faster.
This one has something.
I think the noodle will cool down faster.
The noodle cools down faster. That's something new now, right?
When you-
The
And the
noodle
soup, I
cools down
guess.
faster.
No,
The
it
soup
doesn't.
cool down slower. Do you guys agree what Jason say?
Yes.
No.
Yes.
I think
No.
I think the soup cools down because the noodles are in the soup, so it's always heated.
Yeah.
Or if you take the noodles out of the soup and
Exactly.
If you take the noodle out,
and you hold it.
yeah.
Wait. And you blow.
Okay, you got it.
Blow, blow, blow.
I think the soup is like
Blow five
because
times
like
like
the
that.
noodles. You won't hold the noodles like this.
Okay,
Like stay and wait.
but you're gonna leave for some time and you have to blow it, correct?
Yeah.
Okay. Even for soup, you have to blow, correct?
Noodles every day.
Yeah.
Alright. Okay, I think you guys agree that the noodle cools down faster compared to soup.
Yes.
Okay, you guys agree on that, alright? So then right now, as a smart physics student, before you eat the
Yeah,
ingredients
totally
of the
agree.
noodle, first check which one has the highest specific heat capacity.
Oh.
Which one has the lowest specific heat capacity? So which one has the highest specific heat capacity?
Noodle.
Soup. Soup has the highest. So C for soup is very high, guys. Alright. Okay. And C for noodle is much lower compared to soup. Then you check the vegetable as well. Okay? So vegetable absorbs a lot of water. The more water it absorbs,
the harder
the
it is.
higher the specific capacity.
Yeah, so
Okay?
it's really
Anything
high.
with water, guys, inside.
It is
Water
really
in mushroom. Okay? If it's a hot soup with mushroom, mushroom absorbs quite a lot of water as well. So the C of mushroom could be high as well.
What about the chicken though? It doesn't-
Yeah, chicken, yeah, come back
Like
with chicken now.
I ate once paprika filled with
Ah.
meat,
Yeah, chicken.
and like the paprika was like really
Really
hot.
Really hot,
But the
okay?
meat was not that.
Okay.
So the
You got it, huh?
really, like really hot.
Yeah. So chicken, as compared to vegetable, chicken has a lower specific capacity, correct?
Yeah.
Compared to the vegetable. So think first, next time you analyze, look at, but I think you guys don't analyze, correct? What is important, Malik, is the
My stomach.
yeah, exactly. Number one is the stomach. Second is the taste, correct?
Yeah.
Okay, most important is the stomach and
And
the
the
taste.
hunger.
You eat food,
And
correct?
also the amount.
Sorry?
Also
And the amount as well, yeah. But now you guys start to understand, okay?
Yeah, I know.
So the higher the specific heat capacity, guys, then the lower the higher the heat capacity, the lower the change. Sorry. Hope you guys understand, guys.
Cool down.
Cool down, the temperature will change much lower compared to the one that is a lower specific capacity. So, what's the next student?
Small. Yeah, more probably.
What happened?
Morning, Louis.
So, one more time, guys, okay? So, the higher the specific heat capacity you can see here, the lower the change in temperature. So, right now, again, you have soup and you have noodle. So, noodle has a lower specific capacity. So, the lower the specific capacity, the greater the change in temperature. Okay, clear? So, you bring the noodle out and you bring the soup out. You guys know that the noodle will cool down faster compared to the soup. So first eat the noodle instead of drinking the soup. So that's the theory behind Q equals to MC delta theta. Do you guys understand this? Now easy to remember, am I right? Okay, with the understanding now, you understand what's the relation between C and delta theta. Another experiment can teach you a daily application, guys. Okay, I'm sure a lot of Chinese students, okay, Korean students like to cook the noodle at home, right? Okay, like to cook noodle at home, right? My wife says that my noodle is the best. Okay, she doesn't like to cook. She always asks me to cook. Okay, so I'm good at cooking instant noodle, guys. Okay, all right. So just pour everything in. Okay, and then let's see what happens when you cook instant noodle. You have a noodle over here, alright, and you want to stir the noodle. So do you stir the noodle with a spoon, or do you stir the noodle with a chopstick?
Chopstick.
Why chopstick?
Because the spoon will get hot.
The spoon will get hot. But
No,
chopstick also will
no,
get
no.
hot.
I
Chopstick
mean,
also will get hot.
I use a wooden thingy.
I use
Yeah, it's wooden, you're right. So
Yeah.
why do you use wooden?
It's too
Doesn't
late.
get that.
So which one has a higher specific heat capacity?
The
The
spoon.
C
Oh.
of metal
The spoon is aluminum.
and the C of the chopstick. So which one has a higher specific heat capacity?
Good.
Chopstick.
Chopstick, fantastic, you got it right.
Alright.
Okay, the higher the specific capacity, the longer it takes for the temperature to rise. Clear, guys? So metal has got a very low specific capacity, so the temperature rises very fast, even though the temperature at the beginning is the same. You guys got it now?
Yeah, is
Okay,
that the
okay.
example of what you did there, like the H2O and the
Yeah, aluminum, exactly. It's the same thing. You're right. It's the same thing. I'm just showing you example metal and chopstick. Okay, is it clear? Okay, one more experiment for you. Okay, in an oven, guys, in an oven. Well, oven can go all the way to, let's say, 7. Let's say go to 500 degrees Celsius. Huh? Let's make it all the way that high. Okay. Okay. And 500 degrees Celsius. Okay. Can you put your hand in? Yes.
Yeah.
For 1
Have you
second.
tried putting your hand in?
Yes.
Yeah.
Every morning.
No, you guys have tried, right, guys? I'm sure. You
Yes,
guys
I
take
have.
grease, correct?
Yes.
Okay, let me take grease. 500 degrees Celsius. Okay,
What if
I'm
you
gonna
put
put your hand in.
Oh,
What
where are the
happens?
gloves?
Is it okay?
What if you go like this?
Yeah, what man? You put your hand in, is it fine?
Yes.
Yeah, it's fine, isn't it, Saro? But Saro, then what happens is, suddenly someone accidentally push you, and then your hand touches the
Yeah, then you.
fire, right? So what is different? Inside is 500 degrees Celsius. That metal part is also 500 degrees Celsius. So what's different?
Air. I mean,
let's
you
think
have, to
about it.
open it, you have to open it to put your hand in.
Yeah, exactly. You have to open, go on, go
A
on.
bit of the warmth will go up.
Some heat goes
So
to the
what's
air
different?
particles and then
Compared to air and metal, air also has its own specific heat capacity. The metal also has its own specific heat capacity. Okay, clear guys?
Yeah.
Your hand also has its own specific heat capacity. Okay, so you need to analyze guys, okay? Which one has a higher or lower C? The lower the C, the faster it conducts the heat away from it, or the faster it absorbs the heat. Okay, is it clear guys? Okay, okay. One more experiment, last one. Alright, one last one.
Get it.
Yeah, you guys get it, alright. Okay, also, when you have cooked something that is really hot, okay, that's really hot. Instant noodle, you cook it, right now it's about 90 degrees Celsius. Then Sabrina called Hobby, let's go out for a movie. I want to eat my noodle. Okay, I'm going to put my noodle in the fridge now, okay? At 90 degrees Celsius, okay?
You should not do that.
Okay, so I'm going to put the noodle now in the fridge. Okay, I heard this say something. You should not do that.
When you come back, everything is. Yeah.
Okay. Anyone can explain? Did your mother say that, Hobby, don't do that. You're going to spoil the fridge. Did she say that?
Yes.
Did she say that?
Yes.
How about you guys? Have you tried it before?
Yes.
No, okay. So why did your mother say that? Holly? Your refrigerator will spoil if, let's say, you leave it at 90 degrees Celsius.
Maybe it does spoil.
Will it spoil?
I don't
Yes,
know.
it will. It will.
It will.
Yes.
Sado, explain. Why will it spoil?
Just like it says, yeah.
if you put it in a closed container.
Once you buy it, it says in the instructions.
Sado, don't simply come up with any instruction.
That's
Your own instructions, Sado, alright? Okay.
Okay.
Anyone?
Put it in a closed container.
Close container. No, it's not closed. Open up just like that, okay?
You want to contain the heat.
I mean, the fridge is like at, let's say, 5 degrees, 4 degrees.
Okay,
So it's
30
like,
degrees.
it's like
Here's 30 degrees, alright?
Yeah, I mean, it's still a very big temperature change. So.
Anyone?
Will suffer a lot.
So my question now, very simple
It's
question.
not-
Is it okay to leave the food in the fridge? An easy question, guys, okay?
Maybe it's steaming and that's why the other food gets moldy or whatever.
Moldy.
No, the fridge will get warmer.
Again, your mother says the fridge will spoil.
Yeah.
I mean, you have to cover it. You can't just leave it like that.
So you have to cover.
Even if you cover it, even if you
Fridge
cover it,
usable.
then it-
Because
uh,
I think because the pot has a high specific heat capacity,
The pot has a high specific. Go on.
and the air has a low specific heat capacity.
Go on. No, not
And-
the reason. No. That's not the reason. Anyone? Yeah, Sabrina.
Yeah.
It
No.
can raise the temperature of the fridge.
No.
and
Go on.
other-
Yeah, I can show you that. Okay, so when you put the soup, the noodle soup in over there, it will raise the temperature in the fridge. Continue.
And then other food that cannot stand that high temperature will slowly start to
If you put it, then it
not
will
conserve
consume the other
its.
food.
No, it just
No,
like
that's very okay, but
it
you're there.
mixes, you know.
You're there. It's
It's
very
a
close.
frigid
Very close.
temperature.
Doesn't the fridge use more energy to use like
To cool
keep
it down.
cool?
Okay, Pavel got the answer. Okay, that's right.
Stand up.
Okay, so right. Okay, alright. So the food is 90 degrees Celsius. You put it in. The fridge wants to maintain 30 degrees Celsius.
Yeah, but
So the thermostat detects the temperature difference, then starts to pump freon into the system more to absorb the heat away from the food, so that you slowly cool down from 90 and 13 average temperature. Let's say it brings up to 60 degrees. Let's say, guys, alright. Then slowly cool down from 60 degrees Celsius back to 30 degrees Celsius. So if mom said that it will spoil, actually it's not right. It's just that the motor have to work harder to pump freon into the system to cool it down, which is wasting electricity. That's all basically. So your fridge won't get spoiled.
Okay, it spoils all because of the mixture.
Okay, you guys got it?
Yes.
That's the main reason.
Or
Okay,
eat the noodles
Alright.
and then go to movies.
okay, but not to
Yeah.
say wrong also.
Exactly.
You just keep on doing that, otherwise you're making the motor working harder and harder all the time, right?
Yeah, you
So the
can
lifespan
work
will get lower and lower. Yeah, in a sense, also true long term. Okay. Any question? No question. So you guys understand now how it works? Okay, very good. So this is one part. You guys can don't have to copy down. It's fine. Okay. This is one part. All right. So let's go to the next part. Okay.
Do the questions.
Yeah. Before that, no, we still got a few more to do. All right. So let's do some conversions. Okay.
Right here. Okay.
So let's talk about. Okay, let's look at this experiment. We have a gun.
Gone.
Oh no.
Okay, and there's a bullet inside. And over here you have bag. Filled with sand, guys. Okay. Bag filled with sand. Okay. So now you aim the bullet.
Oh.
Okay, it's moving out. Let's say for Magnum it goes to 600 meters per second. Okay, goes to 600 seconds and directly penetrates the bag and embedded in the sand over here, guys. Okay.
Can I go?
Now, then next my question is, guys, can you immediately touch the bullet?
No, it's
No, it's already hot.
Why not?
It's hot
It's hot.
Hot. Why is it hot?
Because of
friction.
Why is it hot?
Because of friction.
Because of friction between the
and air
bullet
resistance.
and the
sand.
and the sand. So that means what energy is being converted to what energy?
Kinetic to
Kinetic
thermal.
energy.
Yeah, exactly. So for this case, the kinetic energy of the bullet is converted into heat. Okay, so KE is converted to heat, guys. Okay. So what's the equation for KE, guys? Half
And
mv squared.
square.
So what's the equation for heat? So Q equals to Q equals to
MC.
MC delta eta. Correct. Okay. So by knowing the specific capacity of the bullet, then you can calculate the change in temperature of the bullet. Do you know how high it can go? It depends, guys. It can go the way to about 200 degrees Celsius, guys. So don't touch the bullet immediately, guys. It's really hot. Alright, clear, guys? Clear, okay, good. This is KE to Q. So another example. You can also convert from potential energy to Q. Okay, so let's say you have this particular object and you drop it from that height down. Okay. So at this position, what energy does it possess? Yeah, at this position, what energy does it possess? PE, good. So potential energy equation equals to what, guys? mg h, right, guys? After it falls down to the ground or to the table, what energy is being converted to?
P.
Do you hear something?
sound.
You hear something?
So
Sound, okay. Besides sound, what else is generated? Heat, you're right. Okay, so the kinetic energy, the final KE, turns to heat and sound. You're right. So heat and sound. So imagine right now, neglect sound. So no sound is produced. So all the potential energy is converted into heat. So I can say that PE is equal to Q. So equation becomes as mgh equals to mc delta theta. Okay, is it alright?
Yep.
You okay? Okay, a few more situations. Exam can ask all sort of questions, guys. No question over here?
How does it convert it to heat?
Sorry, potential energy, yes,
Yeah.
converted to
How does it like?
potential to kinetic, kinetic to heat.
It converts to heat
Yeah, correct.
when you drop something. Really?
As it hits onto the floor. You take an infrared camera, Saroni-san. If you have an infrared camera or if you watch this documentary on Netflix right now, they can detect they can take a video of what's in the jungle when it's totally dark. Why? Because your body emits heat. Okay, so that's infrared being radiated.
What the military has, right?
Military has it, yeah.
Mm.
So right now those cameramen has it. Okay, so they detect infrared wavelength. So this infrared wavelength is detected by the camera. From there you can tell that that position of your body is very hot. So this part is very hot. Okay, compared to another part, yeah. Okay. Sabrina, got a question?
But doesn't that mean all the PE is converted to?
You're right. All the PE is converted to MC delta theta provided that there is no sound. Assumption must be no sound is generated. Or else you have to add the energy of the sound. Okay, which is not necessary because that's not required. Is it clear? Clear, guys? Alright. So let's go to another few more examples. Okay, another example will be from electricity to heat. Okay, electricity to heat. Okay, you have got a kettle, guys. Okay. So how does a kettle work, guys? How does a kettle work? Anyone? Kettle, electric kettle.
Generate sounds.
Let's say there's no sound, okay? Imagine there's no sound. Yeah, I know there's sound.
But the water.
Assume there's no sound, okay? Okay, so what happened, guys?
Heat is getting generated from the bottom.
Heat is getting generated from
Electricity.
electricity, exactly, okay? So you have this electric coil. Okay, this is a coil, guys. Okay, electric coil or metal coil. Change temperature. Very good. Okay, so this check, guys.
Added by 90.
250 degrees Celsius. Okay. So what's the change in temperature, Sabrina?
160.
160. 160. Okay, so that's good. So this is what I want to see actually. So first, find the change in temperature. And then final temperature, guys. Final temperature, if you say temperature final, minus temperature initial is 160. So temperature final is 160 plus temperature initial. Okay? So just add up 90 degrees and you get 160 plus 90 and you have 250 degrees Celsius. Okay, is it clear? So be careful, right? It's not change in temperature, it's final temperature. And example 3 again, sir?
Yes.
Okay, how many seconds?
714.
Or in minutes, how many minutes, guys? Divide by 60.
11 minutes, 54 seconds.
Thank you, 11 minutes and 54 seconds, okay? Okay, so well, you just write 11 point something minutes is fine, alright? So this is close to 11 point, let's say 11.9. Okay. Is it alright?
Yes.
Is it easy?
Yeah.
Yes,
Can you go
okay.
over it, please?
Which one?
The second one.
The second one. So the second one, mother is just use half mv square
I'll do 4 first.
equals to mc delta theta. Okay? You can see over here, I don't even have math. So because I can cancel out the math. So no math is required. Then it's just half 400 square equals to 500 times delta theta. Is that okay, buddy? Yes. Then find delta theta. Okay. Bring over. Okay, what have you done? Okay. Then just one from there. Alright. Okay, alright. Oh yeah, I forgot to show you one more question. Which the exam also has one more question.
Can you help
Give like
give us
questions
space,
like
more personality?
Sorry?
You should have keep like this question
He's kind.
in the paper.
Okay, so
You're gonna try to kill him or what?
oh, it's
His mother or
let's say 4 example.
Right, it's the L.
She has his real mother.
I watched it yesterday. I didn't read it. Versus everyday stuff like that.
These are kilos.
Okay guys, this is a good question. Let's see how many can solve. Alright. It's a block of aluminium 0.5 kg. Drop it into water at 20 degrees Celsius. The block is 200 degrees Celsius. Okay. The water is 20 degrees Celsius. So as it reaches equilibrium, what's that temperature?
180.
I'm sure 180, not anything. Alright. So it won't be more than 200, it won't be less than 20, okay? It must be in between. But it's not 180, that's simple, right? So please do a calculation now. Okay, what's the final temperature? When is it equilibrium?
And aluminum is 900, right?
Yeah, 900, correct. Yeah, give it a try.
Where the question is.
A good example.
Why did we talk about noodles? I'm hungry now.
Very soon, very soon. So can I go on now? Yeah.
It's
Okay.
74.
Alright. So one last podcast.
Be fine.
Sorry for that. Okay.
Impressive.
Okay, so let's go to the one last part, guys. Okay, one last part. Okay. So Sabrina asked the question, what is heat capacity? That is a very good question. Alright. So heat capacity, C is big C. Definition is the amount of heat required to raise the temperature of an object by 1 degree Celsius. Okay? Again, heat capacity is the amount of heat required to raise the temperature of the substance object by 1 degree Celsius. So from here, you can tell that the unit is not the same. This is joule, this is again degree Celsius or Kelvin, right? So what's the unit for HC, guys? Joule per Kelvin, you're right. Or joule per degrees Celsius. So what's the difference between heat capacity and specific heat capacity?
That's for 1 kilogram.
Exactly, so you must have for 1 kilogram, so the mass must be included. So when you see the word specific, you must include the mass. If there's no specific in front, take away the mass. That's all, as simple as that. Okay, so Brina, is that your question? Yes, sir? Okay, good. So that's all about heat capacity, guys, okay? So Q is going to be just C delta. Okay. Clear, guys? Clear, okay. So one last part. Specific latent heat. So what's the definition for specific latent heat?
This one was
Good. Anyone? Specific latent heat? No one? You must read it, guys. You must understand it. The amount of heat required to change the phase of a kilogram object from one phase to another. Alright? So there are two. Latent heat of fusion is the amount of heat required to change the phase of a kilogram object from solid to liquid. That's latent heat of vaporization. The amount of heat required to change the phase of a kilogram substance from liquid to gas. Formula is the same, it's QOM. We call this latent heat of fusion. Latent heat of fusion. This is called latent heat of vaporization. Is it okay? Okay, what's the unit? Again, this is joule and this is kg. So therefore the unit will be joule kg. Okay? I just want to explain a few more things. Okay, let me show you a graph. Yeah, where is this part? Okay.
in school properly.
Aber dann kennst du dieses Märchen, wo dieser Esel Gold scheißt.
Okay. So this part, the last section, guys, it's a summary of what we have learned so far, right? So let's have a look over here. Now you use latent heat from which phase, from which point to which point, guys? From which point to which point do you use the latent heat? Yeah. Very good, Jan is right. From B to C and D to E, you use latent heat. Okay? So I'll just put the latent heat over here, right? And over here as well. So this is vaporization and this is fusion. You guys understand?
Yeah.
Okay, why during this time there is no change in temperature. Therefore the equation don't have a delta theta. So you need to use it during the change in phase from solid to liquid or liquid to gas. Or gas to liquid, liquid to solid. The other way around also is possible. So when do you use specific heat capacity? When there's a change in temperature. So from here to here you use C. C1. Over here, C2. Over here, C3. Okay. Let's say right now I've got a gas. Sorry, I've got an ice at negative 15 degrees Celsius. This ice is 1 kilogram. How much heat is required to increase the temperature from minus 15 to, let's say, 120 degrees Celsius? Okay. I want to find out how much heat the ice have to absorb so that it will increase the temperature from minus 15 to 120 degrees Celsius. Okay? You guys understand? Okay, good. So a few things you guys need to know. Huh? Alright. So what's the total heat, guys? There's a 1 heat over here, so Q1 plus Q2 plus Q3 plus Q4 and plus Q5. Okay, let's go one by one. What's Q1? What's Q1 over here, guys? Q1, no. ML or MC theta?
MC.
Correct. So MC delta theta 1. What is Q2 here, guys?
Q over
ML.
ML, that's right. ML fusion. What is Q3?
MC.
Good. And is C1. MC2 delta theta 2. What is Q4?
ML.
Correct. MLB. What is Q5?
MCC.
Alright. And C3 delta theta 3. Very good. So just in exam, they'll give you the vaporization specific latent heat. You have the value, just put it in, and this as well. And what's the change in temperature over here, guys? 50.
15.
Over here? 100. Over here? 20.
20.
Exactly. So just set everything up, and that is the total heat. Okay. Is it clear, guys?
You can't do like
Do you know why
a
this is
straight
important?
line, right?
Sorry?
You can't do like a straight line.
So you mean like that? Huh?
Yeah.
No, you can't, because there is heat absorbed over here.
Yeah.
Okay. So why is it important to calculate this? One day you'll be running a factory, correct, guys? Okay, you'll be running a father's factory or your own factory. Okay. So you need to heat up the chocolate. You need to heat up something, guys. Okay, and that heating up takes up a lot of power. Okay, so how much power is needed? You do a budget calculation. Every month, how much electricity is being used? How much I must pay for electricity? Okay, you need to add that up to your sales. Should I sell it more? Definitely, if you can't. Let's say electricity costs you 1,000 euro. You can sell it more than 1,000 your product. It can't be less than 1,000 euro. Okay, so it's always related to your future. So please learn carefully. Yeah? Alright. So no question.